Here, so this is an example for free fall motion, specifically upward motion. Okay, so a ball is thrown vertically upward with a speed of 50 meters per second. How high does it go? So what is the time to reach maximum height? Okay, so you will see here that a ball is thrown, okay, upward. So you will see here that it is thrown at upward here, and it reaches maximum height and it goes back. Okay, so when a ball is thrown upward, there is an initial velocity which is simply equal to 50 meters per second. So let's say this is the maximum height. So at V, at maximum height is equal to 0. So the question is, how high does it go? So what is this h? Okay, and after that, what is the time to go up? Okay, so I told you before that the t up is simply equal to t down. Okay, and the v here, then after that, when it begins to go down, your v equals 0, and your v naught, when it begins going down, v naught will now equal to 0. And you will see here that the final velocity before it touches the ground will again become 50 meters per second. Okay, so this is our given. You have the v naught, of course. The g going up is equal to negative. Okay, so you have to remember that. So using our equation, v equals v naught minus gt. Okay, and at maximum height, v equals 0. Therefore, the negative v naught is simply equal to negative gt. So to find the time, okay, the t now is simply equal to v naught divided by g. The negative here will cancel. So v naught is 50 meters per second divided by 9.8 meters per second squared. Therefore, the time to reach maximum height is simply equal to 50 divided by 9.8. So the answer is 5.1 seconds. Okay? So this is actually our letter B. This is our letter B problem. Okay? So this is for letter B. So this is our B. We got first letter B. Then for letter A, how high does it go? We can use, there are so many equations to use this. So we can choose any of the equation that we have used in our equations of motion with constant acceleration. So for using, let's say our equation will be delta y equals v naught t minus 1/2 gt squared. We can use this. Okay, so we need to find for delta y. So this is the height of the body, and you have to remember that we use negative because it is going up. Okay, so you have to always put the negative sign. It indicates that the motion is upward. So v naught is simply equal to 50 times the time is 5.1 minus 1/2, and g is 9.8 times 5.1 squared. So your delta y is simply equal to, so the answer is 127.5 meters. Okay? 127.5 meters. Okay? So you will see here that I told you when a ball is thrown upward from the ground, the motion is symmetrical. So the t going up is simply the same t going down. And of course, the height up and the height down, same also. And the v going up, v initial and the v final will be the same. So you will see that there is a symmetry here at this part. Even if you go from here, there will become symmetry also. Okay? So this is your v until such time that after 5 seconds, you will get this. Okay there?